Alright, yes, welcome to the session, and I hope all of you guys are doing good. So let's get started with today's session. Today we are going to discuss about LangChain. You must have heard about this term quite extensively, and we'll try to understand this. This session will be more of a theoretical session where we'll try to understand what this LangChain is all about, what all components it has. We are planning to have a series, so this will be a first session where we'll talk about the LangChain, and in future we will plan for having more sessions where we'll talk about practical aspect of the same as well. So let's get started. LangChain is an open source framework for developing applications powered by large language models or chat models. Now, the idea is that when we are creating any applications using large language models or chat models, which we are using these days, like GPT-4 and all, so a lot of interaction happens, right? For example, let's take an example here. Let's say I have a lot of medical documents. And what we want is we want to upload all these documents in our application. And once all these documents are uploaded in the application, I want to ask some of the natural language questions. For example, explain the page number 22 in a document X to a layman. Generate summary for document R in pointers. Give me 10 multiple choice questions from document C. So these are the questions which I can ask based on the PDFs or the files which we uploaded in our application, right? So first of all, we'll try to understand the entire architecture of it. After that, we'll see that how LangChain will help us to achieve the same. So this would be the architecture which we will have. So if you see here, in this particular application, the first thing you can see is the user query, where user will ask any random query. For example, what is the symptoms for asthma? Now it will do a semantic search, right? We'll understand what it is, how it actually works. We'll talk about that. And there is a vector database. We'll again talk about that as well. So basically some operation will happen here. Basically it will pass some of the text. It will do some mathematical calculation and convert the text into numbers. And then that set of numbers, I want to search in my database. And based on that search, it will retrieve certain pages, which are like important for me. And also this user query is getting into this particular system query as well, where user is asking for certain query. And here are the pages which are actually having that information. And based on that, the responses will be generated using the LLM, or you can say chat models. And then the final outcome will be coming in. So you can see a lot of steps present out here, which is actually happening, converting the data into numbers, then storing the data into database, then searching the same, and so on and so forth. So when we are creating any application using large language models or chat models, we have a lot of components which are basically required for achieve the same. So this component we have to somehow manage, right? So we'll talk about more in detail, but this is the entire architecture which we have to build. Now, first of all, what is semantic search? Let's try to understand this. Let's say I have a document which consists of details about asthma, COVID-19, and cancer. We convert this entire text into vectors, right? So basically, machine cannot understand texts. We have to convert that to numbers. And when we are doing that, we are basically converting that to a vectors. So for example, let's say this is my vector V1, which is denoting your asthma. This is my vector V2, which is denoting your COVID-19. And this is my vector V3, which is denoting your cancer. Now there is a user query, tell me about COVID-19. So what happens here is that it is trying to find out the most semantic meaning right? Basically, any vector which are of same type will be more closer. There is a concept of cosine similarity. So we will calculate the cosine similarity. And here you can see that this is the input vector which we are getting. Input vector is coming from the user query. So here what it did is actually, it's a high dimension space, right? I'm showing you in the 2-dimension space, but it will be a higher dimension space. So what is happening here is that it is trying to see that which vector is nearer to the input vector. So here I can clearly see that vector v2 is more nearer to the input vector. That means user is asking for COVID-19. And accordingly, it will generate the response by reading only those pages, right? So that is how this entire thing works. And this entire vectors which we are storing is actually we are storing in one of the databases. And that database is known as vector database. So if you go back to that architecture, which we are discussing here. So this was a vector database, right? Where we are storing all the vectors. There are different types of databases are there in vector database, like ChromaDB is there, FAISS is there, PinCone is there, and there are like various different databases are available. ChromaDB is free of cost. You can very well install in your machine and you can play around with that. So that is the entire thing which happens. Now here is the entire architecture which we have for the same problem statement. The problem statement is that I have a lot of PDFs and I want to upload that PDF. And then after that, I will ask any natural language question. And based on that, it will give me the response. I'll show you one at the end, one application as well like that. But this is what the requirement is. So what happens here? You can see, I told you that a lot of things happen when we are doing or building this type of application. So I have a document which we are uploading. Let's say I'm uploading in the S3 bucket, which is in the Amazon AWS. After that, there is one concept called document loader. This document loader is part of LangChain. So whenever we want to read any document, we have a concept of document loader, which is available in LangChain, which is helping me to read that particular document or load that particular document. So once your document is loaded, then what happening is that you are doing the splitting. Basically, you can also call it as a chunks, right? So we are basically breaking the text into smaller chunks. Once that is done, I am doing the embedding. Now embedding is basically nothing but converting the text to numbers, right? So that is the process happens, and that obviously information will go in your vector database. Once that is done, your user will give some input. That input will also get converted to number. And once that input will get converted to number, I will do the semantic search with my vector database. Basically, which are similars, right? Which of the vectors are similar. Once that is done, the relevant pages will be coming in about that particular topic. Plus user query is also coming in. So it will combine the user query and those pages which are similar to the input which user passed. LLM will read that and give me the response as an outcome, right? So this is going to be your entire architecture. Whenever you are building any application, you can say it's more like a RAG application type of concept. Now, what is the benefit of LangChain? We discussed about the problem statement that, okay, we have to build an application where we will have the PDFs. We'll try to get the insights from the PDF using the natural language processing and all those things. But how LangChain is coming into picture? What is the benefit of LangChain out here? So concept of chain. LangChain revolves around the ideas of chain. That's why the name LangChain came in. So basically one of the components of LangChain is chain as well, which we'll discuss about in some time. But the idea is that it is more like a workflow type of concept, right? Chain is like something like a workflow. So LangChain revolves around the ideas of chains, sequences of modular components that connects large language models or chat models with different tools, data sources, or steps in the workflow. For example, I have an input, then there is a prompt, then LLM, then output, then next action, and then final result. So these are like steps which we are performing. You can create a simple chain, single step, or a complex chain as well, that is multiple step reasoning, decision making, and tool usage. This design allows you to break complex AI tasks into smaller, manageable building blocks. The idea is again the same, right? When we are passing the PDF, after that it will read the PDF, give me the output from the PDF. Let's say I want to add one more process in that. Once the output is coming in, I want to send the email. So one more step is coming in, right? So again, I have to connect that. So basically I can do a lot of stuffs, and all those stuffs can be achieved with the help of LangChain. So let's try to understand this more in detail. So as of now, we are discussing about the benefits of LangChain. So LangChain is basically helping us to generate the entire workflow, right? Suppose I want to do any automation using AI, then LangChain can be one of the tools or one of the frameworks which can be used. There are other frameworks are available, like Creo AI is there, Egno is there. So there are different different frameworks are available. OpenAI created its own framework. Gemini is creating their own framework. So a lot of frameworks are available. But LangChain is like the oldest one, the first one, and that's why it's very much in popular. Second is the model agnostic development. Now, what is the idea? You will understand that. I'll show you in the future slides as well. But every model is having its own API, right? For example, OpenAI, it has its own API. Gemini has its own API, and so on. So every API has its own way of writing the code. The code which we are using for the OpenAI is way different than the code which we are using in the Gemini. So what happens in the LangChain is that it is standardizing the same. If I am using the OpenAI API or if I am using the Gemini API, I don't worry about that. I have to write only one type of code. So basically we are standardizing the entire coding while using the LangChain. So LangChain is not tied to a specific LLM provider. You can easily switch between different models like OpenAI, Anthropic, Google Gemini, Azure, OpenAI, and Hugging Face, Cohere, and many more. This gives flexibility to avoid vendor lock-in, experiment with multiple models, use the best model for each specific use case. For example, today you use OpenAI GPT 4.0. Tomorrow you may choose to use Claude 3 within the minimal code changes. So that is the benefit which you are getting here. That if I want to change my model from one vendor to any other vendor, I just have to change few part of the code, and that is it. And that is the benefit again we are getting using the LangChain. It is giving me the complete ecosystem. So here are the pointers about the ecosystem. LangChain is not just about chaining models. It's a full stack framework for building AI applications. You can consider it like more of a, what do you say, maybe an ETL tool where we are loading the data, we are processing the data, we are exporting the data, something like that, right? So basically everything is happening using the LangChain. It supports prompt engineering. It supports memory handling, tool integration. I can integrate with various databases, file loaders, APIs, search engines, and so on. We can create retrieval augmented generation, that is RAG applications. We can create the agents and agentic AI as well using LangChain. We can evaluate the tools, deployment support, all those things can be done using the LangChain. This makes it one-stop solution to build end-to-end generative AI systems without stitching multiple tools manually. Memory and state handling. Now, LLMs are basically stateless. That means if I am asking that what is your name, LLM, or let's say I'm giving my name, that my name is Rahul, and LLM is now aware of it. But if I ask it again, what is my name? LLM will not able to understand if the memory is not there, right? So the default behavior of LLM is that it is stateless. That means it is not remembering the older conversation. If you want to do that, you have to have the memory of the previous chats. So that also we can take care using large language models, sorry, using LangChains. So it supports multiple types of memory. So when you are creating any application, for example, let's say the same PDF application at the start we discussed, I will upload the PDF file. Once I will upload the PDF file, let's say I'll ask what is written in this document. It will give me the summary. After that, I will ask, okay, give me the outcome in 5 pointers. So in this case, what is required is that LLM should be aware that what was the previous question, because my next response of the next question is dependent on the previous question. So that memory is very important. And if you are not giving the memory at all, the behavior of large language model is it is stateless. That means it does not remember the past thing. So we have to create an application where it should have the memory, and we can do that using LangChain. So here you can see it supports multiple types of memory like buffer memory, stores conversation history, summary memory, stores summarized history, entity memory tracks entities like names, locations, etc. This enables stateful application, chatbots that remember users, agents that keep track of ongoing tasks, workflows that reference earlier data. Without memory, every LLM call is stateless and forgets prior interaction, right? So that is very important, and LangChain is giving me that option of preserving the memory as well. So just think that if I want to create an application which will have something like a pizza bot or any chat bot, so if user is talking to that chatbot, the bot should be aware the entire context and the entire chat which it had with the user. So that's why this memory concept is again very important, and LangChain is enabling that for us. Next is your conversational chatbots. So what it is, build chatbots that can handle multi-turn conversation, remember context, and provide intelligent responses. Can be integrated into websites, apps, or customer service platforms. The benefit is again natural human-like conversation, personalized user experience, can integrate with company data, FAQs, policies, knowledge base, and so on. Reduces customer support costs. Available 24/7 without human intervention. LangChain feature these chains, memories, LLMs, prompt templates. Basically, if you want to build any end-to-end generative AI application in your industry, in that case, what is the idea? The idea is that this is the only thing which we have. Okay. Again, as I mentioned, apart from LangChain, we have other things as well, right? So LangChain is one of the frameworks. We have other frameworks as well, which are available. What all can be built using LangChain, right? So basically, let me come back here. Yeah. So we can create conversation chatbots. We can create AI knowledge assistant. We can create AI agents, right? We can create agentic AIs and so on. Workflow automations. All those things can be created using the LangChain. Document summarization. Okay. Research helpers. Again, I'll share this PPT. You can go through that. Now, the main thing is component of LangChain, right? As I mentioned, LangChain consists of various components, and all components are is having its own use case. The first component is models, right? Core AI model that drive LangChain's capabilities. Second is the chains, sequences of operations for complex tasks. Third is indexes, structures for efficient data retrieval. Fourth is prompts, inputs that guide AI model responses. Fifth is memory, mechanisms for retaining and recalling information. And sixth is agents, autonomous entities that interact with the environment. So these are the various components of LangChain. What we'll do is we'll try to get into each of the components. So the first one is the model. Now I told you that every model is having its own API. If you see in this particular screenshot of the codes, the left code is for the OpenAI API calling, and the right one is for the Anthropic API calling. You can clearly see that there's a big difference in the code, right? One is your OpenAI, where you have a different way of calling the API, and in the Anthropic, there is a different way of calling the API. Now, what is the benefit which we are getting from the models? The benefit which we are getting from the model is that I told you at the very start, if I want to change one model to another model, I don't want much changes. For example, I created the application using OpenAI, but now I found out that no, Gemini is actually more cheaper and obviously it's giving me a good response, for example. So in my existing code base, I don't want to change a big codes, right, in my application. So for that, this model option which we have is making it more standardized. If you see this particular screenshot, you can see that there is a good difference. But now if I go to the next slide, see the difference out here. When I am using OpenAI, left part is the code for OpenAI using LangChain, and right part is the code of Anthropic using LangChain. And see the difference. There is no difference at all. Just we have to call the different packages from LangChain OpenAI import chat OpenAI. Here from LangChain Anthropic import chat Anthropic. That's it. And we have to call that model. Rest of the things are exactly the same. That means if I want to shift from one model to another model, in that case, I just have to change the package and I'm done. I don't have to write or make multiple changes. Few changes and we are done with that. And that is the benefit this model actually giving us. The model component of the LangChain is giving us, right? It is trying to make it more standardized. Second is the prompts. Now, prompt is very important for interacting with the chat models, or you can say LLMs, right? So we want to write a prompt which will be more reusable type of prompt, right? I don't want that prompt should be I have to write the prompt again and again, right? I want it to be more of a reusable. So the prompt component helps you structure parameterized, reuse and manage prompts when interacting with LLMs. Instead of hard coding prompts directly inside your code, you create a template where certain parts are left as variables. LangChain then fill these variables dynamically before sending the prompt to the model. So if you see in the right side here, you can see that write a short story about character, right? So this character will be given by the user, this part. And what do you say? The model will fill that from the prompt which user will pass, right? So if you see here, character is a unicorn and place is a magical forest. So write a story about a unicorn who lives in a magical forest, right? So it's something like a F string type of concept in Python. So we are populating the values here and automatically this prompt will get generated. So the idea here is that I want to make my prompts as dynamic as possible. I don't want to write the prompt again and again. And I know that these are the things which can be dynamically changed by the user. So in that case, we will be going ahead and we will be creating this prompt using the LangChain prompts. There are different types of prompts are available. Here you can see that the static prompt, for example, if you see build a fixed prompt with placeholders, that is variables, handles prompt template. So you can see that here we have one of the modules coming from LangChain called prompt template. So we can use that, translate the following sentence into French, and here the sentence will be given to the user, given by the user, right? So simple but very powerful. Second way is your dynamic prompt. So here you can see that based on the following documents, context, answer the question. So basically here this context will be given by the document and this question will be coming from the user as a prompt, right? So prompt content is dynamically generated at runtime. Retrieval augmented generation, document summarization, database driven prompting, inject search result, embedding knowledge base, content, etc. So in this context, you will be getting all the information coming from the documents. And based on that context, I will ask any question. For example, again, the same thing, right? I have uploaded the PDF. I'm asking what are the symptoms of asthma. So that question will be coming here and context is nothing but the entire PDF summary, right? So that is my dynamic prompting. We have the role-based prompting as well. So all these things can be done using LangChain, right? That's the benefit which LangChain is giving us. that if you want to create any application of chatbot type of concept, you can use certain type of prompt. If you want to create some other type of what do you say, conversational bot, you can use another type of prompt and so on. So for chat models that use roles like system, user, and assistant. So basically, let's say I am setting a system that you are a pizza bot. So that is a system message. So always I am saying large language model that you are a pizza bot. So only ask questions about the pizza which we are offering. So that is the system message which was given by the company. Second is the user. Like for example, you are coming to my pizza store and you are asking for certain pizza. So that is your query which we are passing. And third is basically your assistant. So based on the system prompt and based on the user prompt, assistant will give the response. Right. So that type of thing also we can do. Mostly we are using this on the conversational type of bots. Right. Then we have the few short prompts. Basically, few short prompts are nothing but where I'm giving some examples as well. If you see here, I will have one input, I want output, and these are the examples. Input will be something like this, output will be something like this. So few short prompts are basically nothing but where I'm giving some examples to the LLM as well, so that LLM will understand that, okay, this is the outcome or this type of outcome is what we have to pass, right? So that is again one of the options which are available in the LangChain for us, right? Now the next part is the chains. Now chains is the main thing which we have. As I mentioned that the name of the LangChain is also coming from the chain only. So chain is a sequence of steps where each step can involve an LLM, a prompt, a tool, a retriever, or another chain, right? So as I mentioned that there are various components of LangChain. Prompt we discussed, right? We have other components as well like tool and retriever. We have chain, obviously we are discussing as of now. So instead of calling an LLM directly, you create a pipeline. Chains help you modularize, orchestrate, and control multiple step reasoning. So it's something like a orchestration tool which we have like Kafka and all. So it is helping us to create an entire workflow, right? For example, I'm reading the file. That is first step. After that, I'm converting that to the embeddings, converting into numbers. That is the second step. After that, I'm loading that to the vector database. That is the third step. After that, we are getting a question from the user. That is the fourth step. That is the prompt basically. After that, it is hitting the vector database, fetching out the semantic search. That is fifth step. After that, LLM will understand the context and respond. That is the sixth step. So basically, we have multiple steps while we are doing this entire agentic development or agents development, right? So chains are basically helping me understand that, okay, this could be the first step, this should be the second step, this should be the third step, and so on and so forth. So we can give the entire flow, and that is what chain does. There are different types of chains are also available. We'll discuss that. But here you can see that the benefits which we are getting using the chains. One is modularity. Build complex apps by combining small reusable components. Multi-step reasoning. Split complex tasks into multiple logical steps. Easy debugging. Identify which step failed or needs improvement. Fourth is clean code. Separate business logic from LLM logic. Fifth is extensibility. Easily add memory, tools, retrieval, or custom logic. And last one is deployment friendly, build production grade workflows. Here you can see we have different types of chains are available. One is known as your basic chain, also known as LLM chain. Simplest form of a chain, prompt is there from the user, LLM is called out and output is coming in. If you see in this particular code as well, here you can see that we have the LLM chain where we have the LLM we called and we have passed the prompt. So here I am saying that I'm invoking the chain. That means I'm starting the chain. I am saying that unicorn. Tell me a joke about unicorn. So it will go to this prompt, right? So basically when I invoke this particular chain, this topic will get into this, into a prompt, and your large language model will execute and respond to the same. So it's like a simple chain which we are using. When you have a single prompt and LLM call, in that case, we use this particular concept of LLM chain, the basic chain. The benefit is basically it's simple, reusable, parameterized LLM call, which we have. The second is a multi-step pipeline where I have multiple steps, right? So for example, if you see here, my first chain is there where LLM is called and prompt one is called. What is the prompt one? Give me a title about a topic, right? For example, here we are asking for artificial intelligence. So give me the title about artificial intelligence. So this chain will do that trick. After that, prompt two is there. Write a blog post about title. The title which will be coming out from this particular chain one, I want to write the blog post for the same. So here you can see the flow coming in. Chain one will be called, then chain two will be called. It's a sequential chain. What is chain one? Chain one is nothing but your LLM called for prompt one. And what is chain two? Chain two is nothing but LLM is called for prompt two. What is prompt one? Give me a title about the topic, that is artificial intelligence. And what is prompt two? Write a blog post about that title, that is artificial intelligence. So you can see it's gonna run step by step. First, it will do this chain, it will run this chain. After that, it will run this chain, right? So that is your sequential chain which we have, or multi-step chain, right? Next is your router chain. It routes, right? It's something like if else condition. For example, if your feedback is positive, I want to write an email and appreciate that. If your feedback is negative, in that case, I want to write an email and apologize for the same. So it's like a if else condition. So LLM will decide what to do based on those conditions. So if I want to route and if I want to do something, again, one simple example, I want to create a chatbot where if user is asking for the LMS access, I will be diverting it to the LMS team, right? If let's say there is a fee related problem, I will direct it to finance team and so on and so forth. So this way we can go ahead and we can divert. Here you can see that. So my LLM is called here joke prompt. Tell me a joke about a topic. Quote prompt. Give me a motivational quote about the topic. And default prompt. I am not sure what you want. Please clarify your request about the topic. Right. So we have three chains: joke chain, quote chain, and default chain. Joke prompt will be passed and LLM will be passed. Quote prompt will be passed, LLM will be passed. Default prompt will be passed, LLM will be passed. Now here you can see the router chain, runnable branch. If your joke chain, the topic is basically joke, right? Then it will run the joke chain. And if the topic is saying that, for example here, right, tell me a joke about AI. So it will fetch out the joke from that topic. And if it is joke, it will run the joke chain. If it is quote, it will run the quote chain. And if it is nothing mentioned, it will run the default chain. So we will route that based on the user's input, right? So that is again one of the chains which we have. Now the next part or next component which we have here is your indexes. An indexes or an index in LangChain is a way to store your documents in a format that allows faster semantic search and retrieval using embeddings. It's something like a vector database, right? So instead of keyword search, we use vector similarity search. The documents are converted into high dimensional vectors using embedding models. The vector store holds these vectors. When user sends a query, it's also converted into vector and the nearest documents are retrieved based on the similarity. The way we discussed at the very start of the slide, right? If I go back to the first slide, here we discussed about, right, how the similarity search is happening. So we are passing, tell me about the COVID. It is going and searching for the nearest vector. And you can see that the pink color V2 is equal to IV. IV is nothing but input vector. So it will understand, okay, that the user is asking about the COVID-19. So let me respond about the same. So that is what we will do here. And indexes are basically nothing but helping me to store that information, store the vector information, right? Usually inside retrieval augmented generation, the RAG pipelines, this is the pipeline flow which we have. Load the document, split the document, create the embedding, store the embedding, query the embedding, retrieve retrieval documents, feed into LLM for generation. This entire step will be done by the indexes, right? So here you can see that the components which we have for the indexes, one is document loader. For example, I want to upload the CSV file or PDF file or any web page. I can do that using the document loader. And if you remember in the very first slide, I'll go back. I have mentioned you about this thing, right? Here you can see that the component which we have in the LangChain, which is document loader. So which document you want to upload is what it will be decided by this. And based on that, it will call that particular module. So yeah, here it is. So document loader, load data, which can be PDF, CSVs, or web or something, whichever you want. We can use the document loader function inside the LangChain community. Then we have the text splitter. So basically what do you say? Every large language model has its own context window. Now, what is context window? Large language model can only remember X amount of words at a time. So for example, let's say my PDF is very big. The entire PDF will not be recognized by the large language model. So in that case, what we do, we normally break it into chunks. Why we are chunking? We are breaking the text into chunks. The reason is that of the context window. It can only remember certain words. Certain, obviously, some of the models are remembering millions of words as well, but it has a limitation. Some of the models only remember 8,000 words. So I will be creating 8,000 words chunks. For example, I have a PDF with, let's say, 80,000 words. So what I will do is I will break it into around 10 to 11 chunks, 8,000 words per this thing, right? Per chunk. So that is what your text splitter does, splitting the data into chunks. Then we have the embeddings, converting the text into vectors, right? So that is what we do, basically converting the text into numbers, because the idea is what? The idea is that we cannot process the text. Okay. Then we have the vector store, where we are storing this entire vectors. And finally, we have the retriever, which is helping me to query the vector and get the outcome. So all these are the parts of indexes which we have. Now, what are the benefit which we have using the indexes? The benefit is obviously semantic search is happening, which is good. Second is speed is there. Scalable is there. It is scalable as well. Domain knowledge injection, we can use some private data alongside the LLM, right? That's all something like a RAG applications which we have. Personalization, use specific retrieval pipelines. And finally, modular. You can swap loaders, splitters, embeddings, vectors, stores easily. So these are the benefits which we are getting. Next is the memory. So the next component which we have in the LangChain is memory. So memory allows LangChain to retain information across multiple calls. So your AI app can remember previous interactions, maintain conversation history, track context, or store task state. Normally LLMs are stateless. As I mentioned earlier as well, that if the memory is not there, it will not able to remember what you had discussed in the previous chat. Each call does not remember what happened before, right? Memory solves that problem. So critical for chatbots, critical for agents, customer service, and workflow automations. These are the benefits which we are getting with the help of memory. One is stateful conversation. AI remembers past interactions, personalization, user-specific knowledge retention, complex task reasoning, maintain variables across multiple steps, reduce repetition, avoid asking same question again and again, and better user experience, feels more human and intelligent. Here you can see that we have different types of memory available. One is your buffer memory, stores full conversation history as raw text. The problem with this is obviously more cost. right? If you are having a bigger text, bigger conversation, in that case, you are storing the entire conversation. And if you are storing the entire conversation, what will happen? Obviously, it is gonna be referred again and again, and that will be increasing the cost, right? So good for the short or medium chats. If it is bigger chats, then it's not good. Appends everything together, right? So here is the conversation buffer memory, which we are calling in. So my memory will be set as a conversation buffer memory. That means whatever chat will happen now, I am going to save each and every chat. And each and every chat will be used in every, what do you say, conversation which you are doing. Next is the summary memory. Rather than me storing the entire chat, what if I will store only the summary? That is also fine, right? So rather than me storing the entire chat, I will just go and track the important pointers and I will only store that. So that will reduce my cost for LLM calls. That is good for us. So summarizes past conversation using LLM itself. So basically LLM only will do the summarization, right? So it will understand which are points are important. It will summarize based on that. Prevents token overload, which will obviously save my cost. Idle for long conversation. Under the hood, summary is updated after every interaction. So after every interaction, your summary will get updated. That is what happening in the conversation summary memory. Next is the window memory, buffer window memory. For example, let's say I want to store last 3 chats only, right? So I can set a window that no matter what, I just want to store last 3 chats. That's it, right? So that is your window memory. So let's say I'm chatting. So my previous chats will go off. Only last 3 chats will be preserved, and I will be using that for my further discussions. And then we have the entity memory, which will store all the names, places, dates, etc. So that also we can do. For example, I'm creating one historical bot. So in that case, I will be more interested in the names, places. So in that case, I don't need rest of the information. So I can set the entity memory as well. One we have is vector store memory as well. So vector store memory is nothing but store conversation history in vector embedding, right? So basically it will store the entire memory in a number form. My normal memory is basically we are storing the texts and then converting into number. But here it is directly storing that to number and we are processing that. Enable semantic recall of older chats, great for multi-session assistance. So for example, if you see in the line number 4, we are creating a vector store, Chroma database, and there we are storing the entire memory of previous chats. Now, the last part of the component which LangChain has is known as agents. An agent is an LLM powered system that can make decisions on what actions to take based on user input, available tools, and prior reasoning. Unlike simple chains, agents have reasoning ability, tool calling ability, autonomy to decide steps. In simple terms, agent is equal to LLM plus tools plus reason plus state. Now, what does that mean? For example, let's say I am creating one application where I am using few tools. Let's say I'm using weather API. I'm using, let's say, Go IBBO API. And now I am asking as a user that I want to go to, let's say, maybe Goa. If the weather is good, I want to proceed further for the booking. So this is the instruction which I gave to my agent. Now what it will do, it will understand, okay, he has to go to Goa. First of all, I have to check the weather. What is the weather? If the weather is pleasant, then only I will proceed further and do the booking. Right. So basically, if you want to create this powerful agents using LangChain, then this agent component is coming in, which consists of various tools. You can create your own custom functions as well. You can call the APIs as well, and it will refer to that APIs or custom functions and take the action. I give you a simple example that I want to go to Goa. If the weather is pleasant, book my tickets. So what it will do, it will go and check the weather first. If the weather is pleasant, he will do the booking. Your agent will do the booking, right? So that is again very powerful concept which we can implement using LangChain. Here you can see the benefits. Autonomous reasoning. LLM decides what action to take. Tool usage. Use multiple tools dynamically. Tools as in, again, as I mentioned, APIs, your weather API, your Go IBO API, and so on. You can pass n number of tools. Multi-step workflows can chain tasks automatically. Dynamic adaptation handles unexpected inputs. Error handling tries multiple paths. Highly flexible, can connect to any API or DB or function. So these are the components which we have of the agents. One is the LLM, that is brain of the agent. Second is the prompt template, instruction for reasoning. Third is the tool, that is external functions agent can call. Fourth is the memory, task prior steps, agent executor, main orchestrator, and finally output parser cleans the output, right? So that is the idea about the LangChain and the components of LangChain. Now what I'll do is I'll quickly show you one of the small application where I am going ahead and uploading the PDF. And once I will upload the PDF, I can very well ask questions. Although I did not use LangChain there, but you can see that you will get the idea that what type of application we can build using the large language models. I may have to change the API key. Just give me a second. So you can get the APIs from your API account, that is platform.openai.com. So I'll just create one API quickly. And this API I will be putting in my application. This is the older API, which was deactivated by me. So I'm just changing that to new API. Now, once that is done, I will be launching my application. So once I run this, you can see that this web page is coming in. So this is created on top of your Streamlit package, right, which is on Python. It is asking for uploading the PDF file. So I'll randomly upload any PDF file. Let's say I'm uploading any random, this one, right? So there's the PDF I uploaded. Now you can see that extracting the text from the PDF, generating embedding. Embedding is nothing but converting your text to numbers. That is what happening here. Once that is done, it will store in the vector database, creating the vector database created. I am using the Facebook vector database, which is known as FAISS. Right? So here it is storing the entire information. And once that is done, I can ask any random question about my this thing, right? My PDF. So for example, what is there in the PDF? So basically this PDF is about process automation and AI in process automation, which is created by me only. So once it will search, I will ask who is the owner of this PPT or PDF. So here you can see it's a PDF document, Python handbook by Rahul Tiwari, which primarily deals with the application of AI in operation efficiency and process automation, right? Which all companies were highlighted in the document. So now all is happening with the help of the vector, right? It is not understanding this text. It is converting this text into numbers, and then those numbers will be fetched out. And based on that, it is trying to find the semantic meaning, and whichever is more closer, it is giving the responses. So here you can see that we are getting the DHL, GE Aviation, and Amazon. These are the companies which I talked about in this PDF, right? So that is the idea about LangChain. Obviously, this is not the application created on LangChain, but the PDF, the PPT which I have shared with you guys. So here I have discussed about this entire concept of LangChain. The same thing I can do using the LangChain as well. As of now, the application which I have just shown you, it's not very dynamic. So if I want to make it dynamic and more powerful, then obviously LangChain is one of the frameworks which we can use and we can make it more powerful. I hope this makes sense. Any questions you have, let me know. This is what I wanted to discuss. Kindly use the Q&A. How can you run the model locally if we do not want to run OpenAI key? For that, you can use certain concepts like I'll show you. You have to install Olama in your machine. Right? Runs LLMs locally with ease. So this is my Olama, which you have to install in your machine. After that, you can run all these open source models. Right? OpenAI API, if you are using it, that means you have you are not running it locally, right? If you want to run the local LLMs, you have to download this Olama and then you have to download one of the models out here. You can click on the models. You can download the smaller model, the distilled model. Right? For example, here you can see that DeepSeek. So we have 671 billion parameters, 70 billion parameters, 32 billion parameters. So you may go with these parameters because if I click on 7 billion parameters, you can see that 7 billion parameter is this one. It is going to take around 4.7 GB of your RAM memory, right? So if you are having good amount of RAM, then you are good with 7 billion. If your RAM memory is less, you can go with 1.5 billion parameters as well. So you have to download this in your machine and then you can run that using Olama. That is one of the options which you have. Okay, I see a few more questions coming in. My application will have both text and image as an input. What all LangChain components I can use for efficient context management consideration? Follow-up question can be either previously provided text or image. You can see again, all these components which we have discussed, every component will be used for your multi-model. It just your model will change, right? You will be not using the large language model, you will be using the multi-model. Some of the companies are not allowing use FASs. Any idea why? See, again, it's based on the limitations. FAISS actually is not a proper database. It's a different concept altogether. ChromaDB is a proper database, right? FAISS is basically a package which has all the embeddings predefined. So what happens is that when you are generating the embedding, right, it will compare with the FAISS embeddings. So the concept is not, FAISS is actually not a proper database. That can be the reason why they are not using it. ChromaDB is a proper database. Pincon is a proper database, so they are quite heavily used. FAS is not a proper database. What is the system RAM CPU requirement? Again, 8 GB is not that good, but you can try with 8 GB as well. But in that case, go with the lower parameters, right? Lower parameter models. Will the whole document be converted to chunks, or do we lose any information? No. When you are doing chunking, then you are not losing any information. There is a concept of overlap chunking as well. So basically we can say that, okay, if there are 8,000 words PDF I have, right? I'll create 12 chunks of 1,000, or let's say 2,000, or let's say, yeah, 1,000. So it will overlap. There is an option of overlap. What happens is that first chunk is of 1,000 word. Second chunk will be of 1,000 word as well, but some of the words coming from the previous chunk as well. So we can overlap as well, right? So that the context will be maintained. What are the various considerations for building AI agents in a workflow automation scenario? It's purely based on your requirement. right? The consideration is coming purely based on the requirement which you guys have. How to handle multiple formats, PPT, PDF, store. We can do that same. You have to write the code. You have to load the code. Sorry, you have to write the code in a way that it will load. So as I mentioned in the LangChain, we have various loaders available. So you can just check it out what all loaders are available in LangChain. Right? Document is there, PDF is there, PPT I need to check it out, but it should be there, I guess. If not, we can convert PPT to PDF and we can load that. Is there any debugger that can be used in LangChain to ideally where exactly the model is making mistake and is getting updated in any of the chains? You can create the exception handling code in the Python code, right? So basically we have to use some of the Python properties as well. For processing the log list from the log files, which model should I use? A traditional ML algorithm or some LLM will do my work. See, if the data processing is not difficult, then you can go with any normal machine learning models as well. It's purely based on what is the requirement and which model should be used, right? Many of the tasks I can solve using the machine learning models. So I don't really need large language models. So it's like a analysis which you have to do while building the models. And if you are thinking that traditional models can help me, then why will I go with large language models, right? It's unnecessary cost impact to the environment as well. So you have to see first that how complex the data processing part is. If data processing part is complex but prediction part is simple, then I will be using a large language model for processing purpose, and for the prediction purpose I will use the normal machine learning models. So it can be mix of things, or it can be purely machine learning model, purely data processing using Python, or fully large language models. That is purely based on how the data is. You have to decide that. You can create mix of solutions as well. When doing chunking, if we have table in multiple pages and then also few images within, we lose that data. Any option to get this done? Multi-model we can use for the same images and all. We have to use the multi-models. Large language model will not help. Will the N10 tool we can do this task? Yes, N10 is basically a no code solution, right? N10 ho gaya, and then we have this thing. Which one? Zapier. These are some of the tools which can be used in place of LangChain. If you are not very coding friendly, then you can learn those tools. Why LLM model is important? How implementation takes place globally? Why LLM model is important as in? I'm not clear with this. Is there a plan to show us how to build a? We are planning to have some more sessions where mostly in the next month I will plan to create some basic LangChain solution. Can I suggest some online course where we can refer, get more insights about LangChain? I need to check that. You can go to LangChain website also. That is fine. Are there any alternative for LangChain? We have alternatives. Yes, absolutely. We have Crew AI is there. We have Agno is there. Apart from that, what? I think these two are very famous. OpenAI is coming from its own framework as well, right? So there are various frameworks available, but these are like famous ones. LangChain because it's coming from very start, and Crew AI is there, and your this thing is there. What do you say? Agno, which is earlier known as Phi data. Now it is known as Agno. Okay. All right. So I hope you guys got something new, and we'll plan to have some more practical sessions as well. Mostly next month we'll have one more session. Till then, enjoy and have a nice day ahead.